Hello, I thought I'd show you a tool I'm working on in Python. And basically it will take an image from a PNG and convert it into DEFB, defined byte statements, suitable for an assembler. Now at the moment it only works on monochrome images, such as those for ZX Spectrum. But I thought I would give you a quick demonstration. So I have two test sprite sheets. If we just zoom in here. Now this is 10 pixels wide by 16 high for each of a very popular character. I did this deliberately because it would normally be 16 pixels wide, 16 pixels high for alignment purposes. But this is the whole beauty of the program. So you can define a PNG image and add multiple sprites within it. Also, some developers prefer to add a pixel border around. So I've also catered for this scenario as well. So it won't process the border. There's also the opportunity to convert binary data that you've taken out of a disassembler or in one of the various emulators and convert this back into a PNG image. So I'm just going to go back to here, and as you can see the output is as defined bytes, and it also gives you an ASCII preview of the character. I've deliberately left this upside down for the time being so you can see, and there's also ability to inverse, flip and mirror, which you'll see on this side here. So we'll get going. This works on Windows, Mac and Linux, pretty much anything that you've got Python with the PyPNG module loaded. And I've also added in an Animate. So there's lots of different options that you can use, but let's just get to it. We call Python. It's a generic name. I've called this at the moment. Sprite width is the width inside the PNG image. Sprite height is each sprite is 16 pixels high. The exclude color is the background color. It defaults to zeros, but I've included this as an example. And we're going to read in test data sprite sheet PNG, and the output is going to test output with offset.asm, and I've added in the minus animate. So if I hit return here, you'll see this file has been updated and it shows our character, it shows the defined bytes, and it'll give you the coordinates where the sprite was obtained. And you can see the ASCII preview for each, which is good for your code later on when you're looking at it next year and can't decide which character is which. And then when it's finished animating here, we can stop it. Also, if you want to add assembler type labels, you can add labels. And as you can see here, it's now defined it as sprite 00, sprite 10, sprite 20, etc. So that's the very, very basic, and that took the PNG image without a border. Okay, we can also flip it vertically. So we're taking exactly the same image, but we're just flipping it upside down, as you can see, and the defined bytes are there for you. I don't want to type this all out, so just bear with me. We can also invert the image, mirror it, as well as animate. So here we go. We've taken the sprite and we've mirrored it to flipped it basically on the x-axis, and we've got the defined byte data shown here. What else can we do? So we keep sprite width to 10, 16, because of the way that image was constructed. We're going to add an offset x of 1, an offset of y of 1, a gap x of 1 and a gap y of 1. Why, you might ask? Well, if we blow this image up, the offset here is at 1, 1, we don't start at 0, 0, and the gap between each image is 1 pixel on the x-axis and 1 pixel on the y-axis, thus escaping and not processing the borders on here. So if we go back to here, we can see again it's correctly assembled the sprites. Now this one is an interesting one. So we've got hornbears.bin. This is data that was extracted from an emulator and represents an XY image data. We can process this back into a PNG file. So again, we call up Python, generate a sprite width is 16, sprite height is 16. Test data, it's always got to be on a byte boundary for this to work. Test data, we just need to put that there temporarily for now. It just needs to be a file that exists. I will fix this. Minus sprite data is the actual file, the binary file that we want to process. Binary output PNG is test output hornbears.png animate. So we just hit return. This is this binary data here that has been converted into a PNG image, and we should see here in the test output we've created a 16 by 16 grid PNG that you can then load into your favorite editor and then reprocess. It's still in early stages of development. It's a Python program. It's got lots of different options, as you can see here. So we have simple sprite widths, heights, gaps and offsets for any sprites that have got a fixed border to help artists locate and create their sprite images. Exclude color defaults to black, all zeros, and I've included a tolerance because I found in testing that although the image looked like it had a black background, it actually wasn't. It had an RGB value set, so you can set the tolerance for matching. Alpha threshold, if you've got alpha data in your image, so opacity, you can set the default here. Well, the default is 254, so anything that's not fully opaque will be treated as a background image and be ignored. You can output your assembler as hex and as binary if that suits you. Just set the labels, set the parameters here. You can add labels, add sprite XY. Bin file, so you can take the PNG data and create a bin file that you can import into an emulator. Preview will show you the non-animated data if there is any. Mirror line is what you want to use at the moment. Mirror is not quite working as I'd hoped. Flip vertical, which we saw. Animate is what you've got here at the bottom. You can change the delay of the animation. At the moment the default is 0.2 seconds. Sprite data is the .bin file that you've exported from an emulator. Bin output PNG is the location to where to store the PNG data from that byte data. And then output is file name for your DEFB listing for your assembler. Here we've got the same program running in Windows. Same principle, Python. We call our Python program with the parameters that we discussed. Let's just pull that across here. Hit return. And there we go. So we've created the hornbears as a grid. If you don't believe that, we can move that to the recycle bin, hit return here, and we can generate that again. So there we go, hornbears. Quite simple, really. Windows, Mac, Linux, pretty much anything that you can run Python with PyPNG. Got a simple requirements, PyPNG, that's all we need. You can install your own virtual environment or run it however you see fit. Here we've got the same program running in Windows. Same principle, Python. We call our Python program with the parameters that we discussed. Let's just pull that across here. Hit return. And there we go. So we've created the horn bears as a grid. If you don't believe that, we can move that to the recycle bin, hit return here, and we can generate that again. So there we go, horn bears. Quite simple really. Windows, Mac, Linux, pretty much anything that you can run Python with by PNG. Got a simple requirements, PyPNG, that's all we need. You can install your own virtual environment or run it however you see fit. Thanks for tuning in.